Okay. So last class we had discussed, right? So what is deployment object, and so how to create a deployment object, and what are the deployment strategies. So we've seen, right, two types. One is recreate, and so second one is so rolling update. So rolling update means, and we are giving so minimum ready seconds. How many seconds we have to wait? How many seconds we have to wait? How many seconds we have to wait? And max search and unavailable search. So those and all we pass, right? So these are the main. So inter also many people asking what is the deployment strategies. So how many ways we can follow? So one is rolling update. So rolling means slowly we are going to remove the old parts once the new part is ready. So simple thing is, if you deployed any new version, so immediately we are not going to deploy, immediately we are not going to delete anything. Slowly we are going to delete the old parts once a new part is ready. So that is nothing but a rolling deployment, rolling update. If you use recreate means, so here there is no time period. Immediately it will kill the existing parts and it is replaced by new ones. That's it. Very simple. Got it? So anyone any doubt here? So what is so how many ways? So there is rolling update and recreate. These are very important. Enter also many people they asked just only one tag. So if you want to by default, which is one, which one? If you are not mentioning anything, so what is the default one? Which is the default one? Strategy rolling update. Already last class we seen, right? So default one is rolling update. Suppose if you are not mentioning anything, by default Kubernetes see here. So by default standard default deployment to the Kubernetes. So the rolling deployment is the standard Kubernetes deployments. Okay. So it will take time. It is creating a EKS and all. Just now I started, and meantime we'll see. So clear, guys. Anyone any doubt yesterday class? So what is rolling update and what is the recreate? So and what are the advantage of deployment object? So how to scale up, and so how to check the history and all, and if you have any, if there is any changes, if there something goes wrong and there is some issue on my deployment, if you want to undo, if you want to undo, so these are the kubectl rollout undo deployment, your object name, and hyphen 2 revision number. So already last class we seen, right, practically how it will work, and also we seen this one also, and also we seen. Anyone any doubt to this yesterday class? If it is clear, so let's move on to new one. Clear, guys?
Yeah, clear, sir.
Okay. Now there is one more thing is there. Interview also they asked so many people. So there is one more thing. So this is the approach. Actually, this is the deployment approach. There is two types: blue and green, red and black deployments. So what is blue and green deployment? They are asking like this also. What is blue and green deployment? So blue and green deployment means, so now see here blue and green deployment strategy. The old version of the application nothing but green. The new version of application is nothing but blue. So now if you come to try it, and this is very simple only. And so this is my pod. This is my pod. So here this is my pod. Just assume this is my pod. So here so I deployed one right, I deployed, or just assume so this is our worker node directly. This is our worker node. This is our worker node. And so here so this is my pod. So just assume this is my pod, and here I deployed one version. So this is my pod, and and this is my container so running. Just assume so web hyphen maven app. Just assume 4, tag number 4 is running. So this is everything working fine, there is no issues. So next week or next deployment, I am going to deploy a new version. This is another pod. So this is the another pod. So this is the another pod. So this is also pod. This is another pod. And so here I am going to deploy new version. Same application, web maven hyphen app colon so 5. Now, so what is here green and blue? This is nothing but a green, which is running, which is existing. That is nothing but a green. This is nothing but a blue. Blue is nothing but a newly deployed version. This is the blue. Now this is the green. Now generally end users using this application. So generally, so this is I deployed in production, and so who are using end users using this my application. Just assume this is the end user, so they are so they are using my application. These are the end users, customers. Customers are end users both. Okay, end users. Now I am giving access to my application. So this version is working fine, and these are my new version. So directly I am not giving access to end users. So first what we will do? So this new version, first we are giving access to UAT. UAT, user acceptance test. This is a testing team, and they will test the functionality. See here, same thing here we are explaining. So see here new version is blue now. So deployed at the same time. When both are these deployed, users only access the green only. So right now end users customers are using which version? Older one. This is the this particular tag, this application. Now this week we developed something and we updated some changes, and this is a new version. Okay, so tag number 5. Immediately I won't give access to end users. So first what we will do, we will give access to a UAT team, that is a testing team. Once this testing team is approved, so once this testing team is approved means they will check the functionality, everything working fine, and we will get UAT approval and all. Once everything working fine and we are getting approval mail, and then only slowly we are giving access to, we are removing older version and we are giving access to newer version. That's it. Very simple. Now got it? So immediately we are not giving access to customers. This is running application. This is the old. Okay. Now I deployed new version. So immediately I won't give access to customers. So what we will do? So we will do first we are give access to UAT team. Once the testing is approved, once UAT user acceptance test is approved, everything working fine, they will send one email. They will check the functionality. Hey, there is no issues. Everything working fine. So once they give approval email, and slowly we are removing this one. Slowly we are removing the old one. Slowly we are going to remove this. Slowly we are going to remove this one. So we are removing the, so this link. We are removing the this link, and slowly we are giving access to this new version of your application. So that is nothing but green and blue deployment. Green is nothing but existing application, that is older running application. So blue is nothing but a new version. Now immediately we are not giving access to customers. Once this is UAT approval, once everything working fine, once they send email, and then only slowly we are removing the this version and we are giving access to this version. That's it. Now got it? So that story only here we are updating. See here, when both are this deployed, users only can access the green, where blue is available to your QA team. Blue is available to your QA team. We are giving access to QA team. We are giving access to QA team. We are giving access to QA team. Once this QA team is approved, once they send email, hey, everything working fine, so there is no issues, so now we can use it. So like this, they will send one email. So once that is done, see, after new version has been tested. So once this new version is tested, once everything working fine, so they will send email, they will approve UAT team, the QA team, quality assurance team. QA team will so send approval. Quality assurance team, they will send one email. Hey, everything working fine. There is no issues. Everything working fine. There is no problem. So we can use it. So now then what we will do? Slowly we are removing the this older version of your link, and we are giving access to new version. That's it. Now see here, after new version has been tested and it is signed off for release, the service is switched to the blue version of your blue version with the old version being scaled down. So what we will do, simply we are going to remove the this link. Simply we are going to remove this link and we are giving update to this link. That's it. Now clear guys? Anyone any doubt here? Very simple. What is blue and green deployment? Blue is nothing but new deployment, new version. Green is nothing but so older version. That is running, that is existing. That is right. Here there is no issues, everything working fine. Customers also using. And if you enhanced or if you modified anything, and so we deploy new version. So immediately we are not giving access to customers. First what we will do, we will give access to QA team. We will give access to QA team, quality assurance team. Once they approved, and slowly we are removing the older version and we are giving access to new version. That's it. Now got it? Clear, Krishna Reddy?
Yeah, clear, sir.
Okay, so that is nothing but a blue and green deployment. Or someone is asking red and black also. So mostly people are calling blue and green. Green is nothing but older version. Everything working fine. So blue is nothing but a new version. Immediately we are not giving access to end users. Once testing is done, once they approved, then only we are giving access to customers. Now got it? Very simple. Okay, so under here we are maintaining under the selector, and here we are maintaining versioning, which this is the tag number. Versioning is nothing but a tag number. Versioning is nothing but a tag number. So these are the based on depends on project, depends on your requirement. We can update your metadata file, your metadata file. So but under the all are, I'm not saying under all are following same strategy. Based on project and based on client, we are following so any one strategy. Clear?
Yeah, clear, sir.
Okay. So that is the, so now we got it right. So as of now, how many objects, right, pod, right, how to create pod. Next, RC, replication controller, RS, and namespace, and also deployment. So under the deployment, right, so rolling update, these are the types: rolling update or blue and green deployment. Okay. So this is the rolling update, and one is recreate, right? Recreate. They are expecting this naming convention. Next, green, blue deployment. Okay. So now let's see one more object. So that is the one more object, and what is this? So one more object, Daemon set object. Daemon set. So daemon set is nothing but this is also one object in Kubernetes. This is also one resource. What is that new object? Daemon set object. Daemon set. So daemon set is nothing but this is same like right, kind equal to we are giving daemon set. Kind equal to we are giving daemon set only. Now daemon set make sure that all or some Kubernetes nodes run one copy of your pod. So let me come to here. My cluster is ready. My cluster is ready. And so let me connect my instance. Now we can understand. So daemon set is nothing but this is right in our worker nodes. It is maintaining one pod every worker node. AWS. So login. Now coming to here, sign in. So now already it running, and let me start my so client start instance. Okay. So now coming to here, see here, daemon set make sure that all or some Kubernetes nodes run a copy of pod. Now coming to here. Now if we come to here, now this is my cluster, right? This is my master, and these are my worker nodes. Just assume right now I have two worker nodes. Now right now this is one worker node. This is a worker node 1 and this is a worker node 2. Worker node 2. Now this is your Kubernetes master. Okay. Now if we create daemon set object, so it is maintaining in all worker node one pod automatically. You don't worry. If any new worker node is added, in that worker node also it will create one pod. Which object? That is daemon set. See here, all are some Kubernetes nodes run one copy of pod. Every worker node it is maintaining one pod. That is daemon set object. Now see here, just we are maintaining only kind equal to daemon set. Remaining story same only, no need to change anything. Now when you new node is added to the cluster, suppose here I added right now I have two worker nodes. So if I create any daemon set object, here one pod is running. So here one pod is running, here one pod is running, and here also one pod is running automatically. You don't worry. Suppose if I create one more pod, if I create one more worker node, if I add any worker node to my cluster, so now see here, here I am going to add one more worker node. So automatically what it will do, if we create any daemon set object, so in this worker node also automatically it will create one pod. Automatically it will create one pod. This is also worker node 3, just assume worker node 3. And suppose if you remove this worker node, so this pod will gone automatically, it will go to garbage collector. Now see here, pod is added to the match the rest of the nodes. When the node is removed, when the node is removed from the cluster, suppose if I remove this node, suppose I removed this node, I don't want, I removed this node, what daemon set object will do here, it will delete automatically and it will move on to so garbage collected. Automatically it is removed from the cluster, and also the pod is going to garbage collected. So if you delete the daemon set, clean up the pods is created. So suppose if you delete the daemon set object, so here we created, right, which object we created, daemon set object. Suppose if I delete the daemon set object, so now these are the two worker nodes. So automatically here also it will automatically it will delete the one pod here, here also it will delete the pod here also. So that is the behavior of demand set. So in which case we go for demand set. Now see here. So these are the demand. This is also one object. This is also one resource in Kubernetes. Demand set ensures that all nodes run one copy of pod. As nodes are added to the cluster, pods automatically added to them. As nodes are removed from the cluster, those pods garbage collected. Automatically it will go to garbage deleted and go to garbage collector. So what are the main, see here, running cluster storage daemon on every node and running logs collection daemon on every node. Some of common behaviors. For example, these are my cluster, right? I want to check logs. This my worker nodes. So how can I check it? With the help of daemon set. Now see here, and I want to check the storage. See here, cluster storage daemon on every node. I want to check some common things, and also running node monitoring daemon on every node. I want to check that status monitoring, what is the usage and all. So that case mostly we go for a daemon set object. So that case mostly we go for a daemon set object. So daemon set main purpose is, this is the typical use case of daemon sets are, so see here, storage, cluster storage, logs collection, and node monitoring. And that case mostly we go for daemon set object. If we create any daemon set object, automatically one pod is maintaining in our all clusters. That is nothing but all worker nodes. Suppose if you remove any worker node, so the pod is deleted and it will go to garbage collector. Suppose if we create one more, if you add one more worker node, automatically one pod is created in the worker node. So that is the behavior of daemon set object. Clear guys? Anyone any doubt here? Now got it?
Yes, sir.
So which
Yes.
case? So some of common things. So whenever if you want to, right? So see, running the cluster storage. I want to check storage keep on. and also I want to check the logs keep on, and also I want to monitoring my clusters and all. So these are the mostly use cases. So that case we go for demand set. The behavior is, if we create a demand set object, it will maintain one pod every worker node. Suppose if you delete the demand set object, automatically it will delete all pods in our clusters, in our cluster worker nodes, in our cluster worker nodes. And also if you add any worker node, automatically pod is created. If you remove the worker node from the cluster, so that pod is deleted and it will go to demand, that is a garbage collector. So that is the behavior of demand set object. And which case mostly we go for demand set object? Storage purpose. See here, cluster storage and running logs, logs collections, and also node monitoring. So that case mostly we go for demand set object. Now got it? Now how to create demand set object? So this is same like same as of now, right, how to create pod and how to create so replica set and all same way. But these are the syntax. So these are the syntax. Okay. First let me connect my cluster. So this is ready. Click on this, connect, and copy this. Now see where is PM files. Okay. Now clear the screen. Now check it, AWS EKS list hyphen CLUS clusters. So what is your cluster name? This is my cluster name. Now how to, so kubectl get nodes. So now we cannot see, we cannot get it. So now see here, unable to connect to the server. So unable to connect to the server, and we are getting some error message. So what is no such host means, right now we didn't configure. Now configure. So AWS EKS update hyphen cube config, update hyphen cube hyphen name. So what is your cluster name? Copy this cluster name and just paste it. So that is just now my cluster is ready, right? Now see here, updated my config file. Now check the nodes. How many nodes ready? kubectl get nodes. kubectl get nodes. So now see here. So right now I have two worker nodes. Right now I have two worker nodes. So right now I have two worker nodes. Now kubectl kubectl get pods. Now check it. Do we have any pods as of now? No, we don't have any pods, right? So let me create a demand set object. Now see here, kubectl. First let me go to my directory cd space, so dev ls, and I'm going to create sudo vi sudo vi d daemon ds daemon hyphen pod dot yml dot yml. Okay. So ds means daemon set. Okay. Now insert, same story only. See, API version. So suppose if you don't know, just Google it. Already they will provide same thing. See here. So what is this API version app slash v1 kind equal to, just we need to update the daemon answer. That's it. Now already here we have some script, right? Now see here. Here I am using nginx server. So let me copy same as it is. Already I hope everyone know what is nginx and how it will work. Correct? Already sir explained many times, right? So how to configure nginx and all. Now coming to here. Now just I am adding the same, I'm going to update. Okay. So now see here, API version app slash v1 find equal daemon metadata, and so what is this name equal to nginx hyphen ds, and the spec, under the spec selector, under the selector match label pod and app. Okay, nginx. Next template, under template metadata name equal to, next labels, under label name. Okay. Next, this is the which section? This is the node. containers, okay, hyphen name, image, okay, ports, next container port, okay. So node selector, node name, okay. Anything missing? So API version, what is this API version? So app slash kind equal to daemon set. This is the mandate daemon set. So nginx, and so here I am taking nginx only. Here node selector also no need. Okay, so directly I am giving containers, and so I am not going to specific node. I want to all. So name equal to web server and image equal to nginx. So next container port. What is the default container port? Nginx 80, right? Tomcat 8080, nginx 8080. So that's it. Okay. So now anything missing? Any indentation? So selector, match labels, app, template, metadata, name, nginx labels, okay, spec containers. This is my image name. This is my container port number. Clear, guys? Anyone any doubt here? Same only. Just we need to update the kind equal to daemon set. That's it. Remaining story, I hope everyone know what is the same syntax. Clear? Yes or no?
Yeah, clear, sir.
Okay. Now coming to here, let me save escape colon x. Now kubectl apply hyphen f ds hyphen test dot yml validation something indentation unknown field match labels, unknown field spec, missing required field template, if you choose to ignore then indentation problem, mm, just edit where it is missing kind up to here correct selector match label. Now see here metadata name, namespace I don't want namespace, I don't want spec selector match label template metadata label spec containers, okay. Now metadata match template to metadata we need to give space, and spec also it is sibling of template, it is sibling of template metadata we need to give here space, okay. Here insert space, and so name, next to label, okay, next space, next this is the template sibling, okay, containers, and okay, image port, that's it. Now see here, check it here. So spec selector and match labels name, so this is selector parallel to template, selector parallel to template, okay. Next template, this is metadata and spec, so these are parallel under template two siblings, so this is the okay. Now escape colon x. What is this? Validating ds error, validating here unknown field match labels, match labels, match labels, selector match labels name. So spec selector match labels name. What is here? Spec selector match labels. This is also indentation problem. Go to insert to selector. After selector, so there is a space. Okay, this is a space. Now, okay, escape colon x. Now check it. If CTL apply ds hyphen. Now it is created. So now see here total how many worker nodes we have. Total how many worker nodes we have? 2 or 3. My cluster kubectl get nodes. How many worker nodes? How many we have here? 2, right? Now check the parts. Kubectl get parts. Now how many parts it is created? One or two or three or four. As for your knowledge, just now I explained it, right? So if I create any daemon set object, every worker node it is maintaining one part, right? Now got it? Every worker node it is maintaining one pod. Clear or not?
Yeah, yeah, clear, sir.
So now check it. Now see here how many are running. Two. Suppose if I remove any one cluster, if I remove any worker node from my cluster, so what it will do? This pod will delete and it will go to garbage collector. So let me go to here. Let me go to here. Where is this? Here I am going to wantedly. I want to remove the. I am going to shut down. Okay, I am going to select this one. I am going to here and terminate. Okay, I am terminate the one worker node. I terminated the one worker node. Now, as for your knowledge, now how many parts we can see here? One or two based on this diagram. If we remove any worker node from the cluster, the pod also automatically delete and it will go to garbage collector. Now got it?
Yes, sir. Yes.
Okay. Now I shut down one. Now check it. So how many nodes we have? So first check it. How many worker nodes we have? So kubectl get nodes. Now still it is not so deleted. Just wait. Where is this? It will take time, right? Just wait. So we'll check it. Now not ready. Now check the parts and all. Now check the parts and all. Now still it is there. Not ready. Anyway, it will update. Anyway, it will update. So anyway, it will going to delete one pod. It is going to delete one pod. So that is the behavior of so daemon set object. So this is the if any new node is added to the cluster, pod is added to that pod is automatically added to that node. If that node is removed from the cluster, the pod is garbage collected. It is deleting and it will go to garbage collector. Clear? Anyone
Yes,
any
sir.
doubt here? So this one. Now there is one more object is there, stateful set object. So this is very important. What is stateful set object? Many people ask in interview also. So stateful set object. This is one more object. Now you know what is so daemon set, deployment RC replication controller, replica set, pod, and namespace and all. Now there is one more object is there, stateful set. Stateful set. So now if you observe here, if we create any pod, if we create any pod, so if we create till it is if you come to here, it is terminated, right? So it is based on right, auto scaling. So automatically it will create one more worker node. So who will take care of this all these things? AWS people, the vendor. We are using EKS, right? So even if you delete this one, so automatically it will create one more. See here, one more pod also it is created. One more pod also it is created. Now one is permanent, it is not fully deleted, but automatically it is created one more pod. Now keep CTL get nodes. Now one is so now that is one and one is already automatically ready. This is here internally it is they are maintaining auto scaling. So with the help of auto scaling, automatically it is created one more worker node. So even if I delete two worker nodes, automatically it will create so two more worker nodes. So here everything taken care by AWS people. In our script, so we are maintaining. So how many we need? Desired we given right? Desired how many you need. So in script I added right here. So there is a script is there. So in the script, so minimum decide how many you want. So maximum how many. So those and all already we mentioned here. So based on this only it will work. So if you go to here, so there is one file is there. So EKS cluster. So not EKS main.tf file. So here we configure already. So now observe here. So if you go to here, not here, this is access key and right. So this is the EKS cluster. So here I already we configure some. See here minimum 1. So decide. This is which script I think 2, right? Decide. This is not correct path. Somewhere I updated. Okay, this one somewhere. So decide means here we are maintaining. This is not actual path. This is here maintaining 2 only. Maybe I didn't so updated. This is actually I didn't save. Control Z. Here 2 only. We are maintaining desired size 2 worker nodes. Even if you delete one, automatically it will create one more worker node. So now based on this only it will work. Anyway, we'll see later. While if you know Terraform, so that time we will understand more on this. Right now there is confusion here. Okay, leave it. Now there is one more object is there. Stateful set object. Stateful set object means this is very important in real time also. How it will work? See here, deployments are usually used for stateless applications. However, you can save the state of your deployment by attaching the persistent value to it and make it stateful. But all of the parts of the deployment will be sharing the same value and data across of all of them will be the same. In Docker, you know, right? Docker volume. You know, right? Docker volume. I hope everyone know, right? Docker volume. Okay, so in Docker volume, there is two ways we can configure, right? What is Docker volume and what is the main purpose, you know, right? In same way, if we come to Kubernetes, there is a PV, persistent volume. Shortcut we are calling PV, and there is PVC, persistent volume claim. So next class we'll see. So PV is nothing but this is a volume. See here how it will maintain persistent volume, and it is stateful, but all the parts of the deployment will be sharing the same value. So if you want to save some piece of data, you know, right now, if you want to save some piece of data, so in Docker also we are using Docker volume concept, right? Bind volume, Docker volume, you know, right? So how to configure, how to create a Docker volume and how to attach your volume to container. And so, you know, right? What is the main purpose? If you want to copy or if you want to, even my container is deleted, even my container is deleted. I want to get that data. I want to get save my data. So how to configure with the help of Docker volume we are configuring. But same concept if we come to Kubernetes, that is persistent volume and PVC, persistent volume claim. Okay, so this is also same volume concept. We'll see now. So here stateful set is the Kubernetes resource and use it to manage stateful applications. It manages the deployment and scaling of the set of pods. And also the main thing is it provides guarantee about the ordering and in-queue of these pods. Now you know, right, how to create pod and all. Let me delete this all these things. So I am going to create one pod. Kubectl, 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 delete, space, all, hyphen, all. Now I am going to delete all my existing resources and all. So let me create one pod, ls. Okay. Now I'm going to create our RS or deployment, you know, right? There is some object is there. We can use anyone. Now see here, kubectl, kubectl, apply, hyphen F. So yesterday we used, right? So what is this? Mm, something duds, not here. I am using here, right? ls. So now see here, kubectl, apply, hyphen F, deployment I am using, so recreate I am using, okay, deployment recreate, okay, anyone, we can use anyone. Now here, so I have two parts, kubectl, kubectl, get parts. Now how many parts we are maintaining here? Two parts, right? So how many parts? Two parts. So for each pod has one name, right? Each pod has naming convention. See here, this is your deployment object name and this is a pod. It is giving some name, right? Pod name. Now, if we use the Daemon set object or if you use a replication controller or if you use replica set or if you use a pod. So if you delete this pod, what it is happening? It will automatically it will recreate the one more pod. See here, my two pods are running. Now observe here, kubectl, 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 delete pod, pod name. Now I'm going to delete this pod. Now observe carefully here. I deleted one pod. So here anyway I am maintaining replicas and all. Automatically it will create one more pod. Correct? Here anyone any doubt here? Now automatically one more pod is created. Now is there any guarantee my pod is giving same name? Pod is deleted. Immediately one pod is created. Is there any guarantee we are getting same name?
No, sir. Initial.
No, no.
This is different name, right?
Yes, yes, sir.
But if we come to real time, for example, if we come to real time, now observe here. So this is my front end application. So this is my back end application. So back end is running one pod. Back end I deployed the DB and all. We have one pod. And this front end and all we deployed another pod. Now both are connecting via REST API and all. These are connecting internally. You don't worry. You are not developer. So leave it. Okay. Now unfortunately this pod is deleted. So for this we have one pod and our application is also deployed and DB also running. So this information and all they configure in our application side, right? Correct. This is my application. In code level already they configure DB and all. That my pod name and that DB connection and all. But whenever this pod is deleted, so as of now, if pod is deleted, automatically it will create new pod. Automatically it will create new pod. But the pod name will change, right? Pod name every time it is changing. There is no uniqueness, right? Correct? Now see here. Now I'm going to delete this pod. Now observe here. Pod will create, but it is not giving unique name. Now see, I am giving here. Now pod is deleted. Now automatically pod is created. Do we have any uniqueness here? Pod name changed. How can I configure? How many times I can configure in developers in your application side, right? This is very difficult, right? So for that, so to overcome this problem, in Kubernetes they will provide one object. What is the resource name? Stateful set object. Stateful set object. So with the help of stateful set, see here, it will create pod with the name. Or the one thing is here we need to understand that their names will be increment. That this is the main. See here, so it doesn't create the replicas rather than we create the pod with the unique naming convention. I want to same pod name. Even pod is recreated. You don't want to change my pod name. I don't want to change my pod name. I want to create uniqueness. I want to create uniqueness. That is nothing but naming convention. For example, this is a MongoDB. Here we are calling like MongoDB. Just assume. So here we are using some so SQLDB or any DB. So SQLDB. Okay. So SQL or Oracle DB anything. SQL. So this is the SQL1. So even this pod is deleted. This is my pod name. If this pod is deleted, I want to give same name or I want to sequential order SQL2. Just assume we are maintaining replicas 3. We are maintaining replicas 3. So by default here three pods are running SQL1, SQL2 and SQL3. These are three pods. Unfortunately, this pod is deleted. SQL1 pod is deleted. Now which name it is giving? Same sequential order, same sequential order. It won't change any order. So that is the meaning here. Now see here. So if create a stateful set with naming Mongo, it will create pod with the Mongo hyphen 0, Mongo hyphen 1, Mongo hyphen 2. That is naming convention. That is the sequence of multiple. Here we are maintaining multiple replicas. We are maintaining multiple replicas. So with the help of this, we are maintaining same name, same sequential. So interview also many people they are asking what is stateful set object? What is stateful set object? Why we should go for stateful set object? Now got it? See here, stateful set is Kubernetes resource used to manage stateful application. Manage stateful application. So if manage the deployment and scaling of your pods and provide the guarantee about the ordering and uniqueness of these pods. This line you need to remember. It will provide guarantee and ordering and uniqueness of all pods. It won't change pod names. It won't change pod names. Clear guys? Remaining story same as usual. Now got it? and also each pod has some persistent value, and also each pod has some persistent value and PVC also. So anyway, we'll see next class. So now got it right, why you go for stateful set object. So if you go to stateful set object, we are maintaining guarantee about the ordering and uniqueness of these pods. We don't want to change every time pod. Even pod is deleted, I want to give same name. I don't want to change. Now let me create one object we can understand. Now anyone any doubt guys here? Sudo vi stateful yml. Okay. So insert. Now let me copy, or we can copy from Google also, no problem. So here nothing, right? So now coming to here, so stateful set, stateful set. Okay. Now if you see here, stateful set is the workload API objects used to manage stateful application. If your application want to maintain stateful, so that case we go for stateful set object, manage the deployment and scaling of set of pods and providing guarantee about the ordering and uniqueness of all of these parts. Same story only. Now these are the limitations and all. So these are, we'll see next class. So for the time being, just create one stateful set. This is a service, right? So where is stateful? This is a stateful. Or else copy everything as it is. Same thing. Few keywords are new, right? We'll see later. Okay. Now if we come to here, this is a service object. So actually this is a service object. So insert, enter, hyphen hyphen. Okay. So now, so here dot. Okay. Now delete. That's it. Okay. Now this is the main API version app slash v1 and kind equal to stateful set object. Which object I selected? Stateful set. That's it. So metadata. This is also not mandatory here. Right now I am not going to use any service. I am not going to access and all. So just simply I want to show how it will create. Okay. Now stateful and match labels nginx to be matched service name nginx replicas and all, and the same thing only. And image I am going to create nginx. Here they are using different image. I don't want this image. I am going to use my image, or else so what is the linux command undo u, right? Only capital U or small u? Okay, register, right? Let me use same object, same image, so whether it will work or not. So if it is not working, so this and all we don't want. So volume, okay, or else give as it is. Now main thing is this is metadata, we are giving web. That's it. Now escape colon, leave it what is the content and all. Just let me create kubectl apply hyphen f, and so what is the name? SF pod. So now pod is created. Now see here, kubectl get all, get pods, get pods. So now pod is created. Now pod is created. So let me delete existing pods and all. I don't want. So kubectl delete, delete, delete all paste hyphen hyphen all. Okay. Now it is deleted. I am going to create only stateful. We can easily understand how it will work. It's taking time. So stateful set abstract web is deleting. Okay, deleted. Let me create a stateful set object. So kubectl, so kubectl apply hyphen ds. Now see here, kubectl get pods. How many pods created? Only one pod. So only one pod, web 0, only one pod, right? Web 0. So it is created, it is pending, status is pending. Let me check it. So kubectl dsc describe, what is the object name? Okay, just check it whether that is available or not. Create pod web stateful web resources successfully. Okay, read and write. We'll see later this and all. So this is the image. This is the image, and so replicas desired, three desired, one total. Okay, is desired one total. Let me say kubectl get parts. Still it is not creating. Okay, okay. Mm, 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 mm. Now simply I am going to edit. So kubectl. So there is some problem. The PV and PVC problem here. Kubectl delete all all. I'm going to give very simple. Okay. Sudo vi sudo vi. I don't want all these things. Okay. I'm not going to use any PVs and all, and image also I'm going to change it. We'll see later this and all. Okay. Now simply stateful web selector match label service name replicas min ready seconds. So these all are not mandatory. Okay, leave it or else remove. These are new, right? So template metadata nginx and termination grace period. This is also you don't know, right? Leave it. Okay. So containers and nginx, and here I am going to give image name. Nginx is working. Any idea? Nginx which version? Okay, nginx. I am giving only nginx. Port is 80, and so name also this is and all already you know. Up to this you know everyone. So how many replicas we are maintaining? Three. Escape, escape, colon x. Okay. kubectl apply, kubectl apply hyphen ds. Did not find expected key. Which line? JSON line number 10. What is the line number 10? I think service name. Leave this one. Insert. Okay. Escape colon x. Replicas 3 template selector match label APC template metadata. Metadata insert. Where is escape colon insert? So template metadata. Okay. Wait. Okay. Metadata labels templates selector. Up now this is used tab. Okay. Now use this one tab. That's it. And the spec right on the containers name image and all. So spec selector match label this and all correct only. No problem. Okay. Escape colon x. Mm. escape colon x. Okay, now run it. Stateful set spec missing a required field service name. You choose the ignore else false. It is expecting a missing service name. Okay, so now we need to add service name also. So insert where we need to add service name. So under the selector replica stop. So replicas escape you. Okay, now go to here. Is control paste. Okay, selector parallel, right? Selector parallel escape colon x. Now replica set as object is created. Correct. Now check it how many cubes it will get parts. So now so three are running. So this is the one part, this is the one part, this is the one part, and this is the one part. Now see here cat space cat be stateful. What is the object name? Which name you given? SF. Correct. Cat space SF pod. So now see here we given so metadata name. So now if you come to here template. So here which name here given, right? So web. So metadata name web and created web 0, web 1 and web 2, web 3. Three parts is created. Now let me check it. I'm going to delete one pod. Now we can easily understand. Now see here earlier if I delete any pod, so this name should be changed, right? Now I'm going to delete. Whether it is deleted or change or not. Keep CTL. So delete pod and pod name web hyphen 0. Web hyphen 0. Now pod is deleted. Now check it. Already replicas, right? How many pods we can see? It is giving the same pod name or it is changed. See age also we can check it. 4 seconds ago it is created. If you use any deployment object, if you use any replication controller, replica set pod, if pod is deleted, if pod is recreated, every time pod name, same name it will come or it will change every time. Pod name
Change, sir.
changed. Now this stateful set behavior, it won't
Same.
change name. So that is the behavior of stateful. See here, it is providing guarantee about the ordering and uniqueness of these pods. I don't want to change every time pod name. Even pod is deleted, pod is recreated. I want to give same name to uniqueness of the pod. We need to follow uniqueness of the pod. This is nothing but ordering and uniqueness of these pods. Now got it? So that case mostly we should go for stateful set objects. So which objects mostly we are going to create in real time? DB and all. Mostly stateful set objects used for DB purpose. Which purpose? DB configuration and all. So that case mostly we go for so this stateful set object. Now got it guys? Anyone any doubt here? This is the main remaining story and the same only. But this is the main. So why you should go for even my part is deleted, even my part is recreated. So every time it will give different name. I don't want different part name. I want same part name. I want to assign same part name. So that case we go for stateful set object. Now got it? Clear
Yes, sir.
guys? Okay. So that's it from my side today. And so remaining things, so we'll see next class. And that is what is persistent volume. That is we need to understand few more things. Once I explain all those things, so then only we can understand the remaining part. Okay. So that's it. So if we have any doubt, we can ask, or else we'll wind up and we'll connect.